Hi everyone, this is John Wen. Today is January 21st, 2020, and I will record this video to briefly talk about what have been done in past week. So let me briefly change the date here. So I think it's fine now. So I still work on two items, and first item is to write the first paper with application. And so you can see the progress is about 15% progress for this week. And for the second one, I stuck in an error, and I currently try to seek the help from Bai and see if he can help anything from his end. So let's get into the detail. So for the first one, um, since last time we encountered the issue with the Conda, so I tried to uninstall the Anaconda, and I'm trying to set up a TensorFlow GPU version directly, but I still in progress. I didn't finish yet, and hopefully can trigger the Python code on the GPU and directly. So the next item I tried is to directly program on GPU within the data view. So I've successfully created a adding workflow GPU version workflow in data view that can with two input files and contains in two integer array, and it runs with the Aparapi kernel on GPU, and it is able to output correct summation for each pair and save to the output file. So I also set up adding workflow CPU version for comparison and compare the performance. By so far, I noticed that for the add operation, the CPU performance is better than GPU. So maybe it's due to the lack of parallelism requirements. So let's get into the code and see what it's doing. So if we are looking at the test.java, and here we call a add workflow GPU class. And so if we take a look at this add GPU, actually we only take one, we have one input, and this is a reversed version from the initial. I take two files as input and add two files array of vectors and pairwise. But right now I just have one input, that is to define the size, and then we randomly generate array because I have to compare the CPU version and GPU version with a huge amount of data that it can be compared more wisely or reasonably. So here I have only one input as a number, that is a size of array, and we have an output as a number 3 text. And let's take a look at the task file, and this is a task add GPU, and what we are using is using the here we're using the Aparapi kernel, and this is a project that initialized by AMD, because as far as we know, they're two most famous or most practical library. One is a JCUDA, and one is a Aparapi, and one is from NVIDIA, and this one is from AMD, and this one is more generous, and it does not have limitation. That's only limited with the NVIDIA GPU. So that is one advantage we may take from this library. So if we can see, we prepare the data, and depends on the size we input, and we have initialize an array of the randomized float, and then we put this into the kernel. We do some preprocessing and then put into the kernel and add them together, and then output the final result. So I think, yeah, here is a final output, and we use a string builder and to put it into the text number 3.txt file as a final output. I also set up a CPU version, that task add CPU, to do the comparison. What I noticed is that the performance for this task is it, the CPU is over the GPU. So I think it's due to not very intense or heavy parallelization needed for this task. So currently, um, let me show you first the CPU version. So you can see I mark as a CPU or GPU. Let me see. Okay, so I think we can start from here. Okay, so this is a random gen because we randomly generate. This is a CPU version that is direct comparison with the previous running kernel. So so the result is that because I don't have a GPU right now, maybe I cannot show you the result of performance comparison. Currently, I'm also working on a further one that is a convolutional GPU task. So that is more parallelism intensive compared with add operation. So hopefully, the convolution or polling will utilize GPU more intensively, and we can gain some performance from the CPU over the CPU. So let's see. That is hopefully will be done by next week, and let's get back to the slides. So yes, um, let's get to this page. Yes, so for the third item, I further work on a convolution workflow on GPU and CPU implementation, and we'll see if we can get better performance on the GPU. During the weekend, I also have a very good time and discuss with Dr. and thank you so much for his time. And I obtained multiple very useful, practical suggestions on how to write a good survey and working on the review, the paper that include in the survey, and also I also added a section of the future work that provides some foresees on what I think that may come with the scientific workflow on coming years. So if we take a look at the paper I have right now, so I mainly added the okay. So let me see if yeah, I think this one, and I added future work parts and to discuss few that for things that may happen in the scientific workflow area. Maybe we can further implement it and illustrated some examples here that will strengthen our solid our suggestion or our promotes here. So I also still work on the comparison charts, and by reading through the papers that is also suggested by Dr. Che, and to review the papers including in this survey and make sure all the important thing has been covered. Okay, so I think this is for the first item. And for the second one, I still encounter the error, and I didn't. I tried compile and debugging several times, but it does not work. So I emailed Bai with some of my questions and see if he has better insights and about what could be the root cause of this error, and some further ideas, what I found and what I see. So far, I think this is updates for my this week, and thank you for your time. And until next time, happy coding.